In 2005, they said that there were 35% of the students were non-traditional over the age of 24. And so all of these things make for a changing learning environment. So what made us want to move our LMS to a cloud situation? Well, it varied with every institution. So Athabasca University was looking for disaster recovery and business continuity, which creates happiness in the Office of the Auditor General and makes for better sleep at night. NATE, Northern Alberta Institute of Technology, was looking for stability in their platform. They weren't happy with what they were providing themselves locally. And we at the U of A were looking to learn from those who transitioned to Moodle ahead of us and share with those who were moving after us, and then saving money in the long run. And everybody wanted to share knowledge and experience. Recreating the same wheel over and over was not something we were interested in. So we took 4 actions. We developed a business plan on what to do about collaborating. And we selected one of the options. I'll go up about that. We set up governance and operations of the Cloudscape, went through startup and have gone into production. So we shared our business plan in early 2012, and there were 4 options that came out of this. Every institution carries on themselves, status quo, or thereabouts. Every institution outsources to a corporate host like Remote Learner or one of the Moodle rooms, something like that. So that's expensive. There's no collegiality, no learning. Not really the method we wanted. One institution can host for all the others. So say the U of A hosts everyone else, which is kind of the BCNet model as I understand it. That created political ramifications that we didn't really care for. One would feel like they were always the service provider and the rest would always feel like they were indebted. And the 4th option was a partnership through a nonprofit organization. And that was the selection that we made. But when we started out, we said, well, let's start a new not-for-profit. We had UDigit, which helped us all collaborate on licensing Oracle and PeopleSoft in Alberta. But starting that new not-for-profit would require hiring a CEO. The CEO would have to go out and find finance and legal and operations and technical, which would take months, if not years, and we were not willing to go slowly on this. So in parallel with the technical setup of the cloud environment that we were looking to do, hardware, software, networks, and the like, the partners developed governance and operations documents on this. And these documents were developed collaboratively and edited iteratively amongst the institutions. So these got passed around several times between Athabasca and NATE and the University of Alberta. Cybera worked on the operations document a lot. So that really helped. So about 18 months ago, we were wondering what to do next, right?
We were. So we'd spent the last 18 months or 2 years or so building infrastructure as a service clouds and playing around a lot with clouds. And we'd done this enough to understand the limitations of just infrastructure as a service. We knew that to get the full potential of a cloud, you needed to have additional tools and processes to work with that cloud. And we wanted to find out more about that. So we were looking for a project that we could really sink our teeth into. We understood that to really understand a new technology, any fool can set up something new and get it running in a live environment. But to really understand it, you need to run it at scale in serious production. So we were looking around for a project, and the University of Alberta and NATE and Athabasca got together with us. I'm with an organization called Cybera. That's our mission statement up there. And it kind of makes it sound like a bunch of Boy Scouts, but it's the real deal. In a nutshell, we look at new technology and we try to figure out how to make it work and what it's good for. And we also run the Research and Education Network in Alberta. So there's a good chance that you and I have actually worked together sometime. I mentioned that we use an infrastructure as a service cloud, and I want to be careful to distinguish between between cloud and near virtualization. The important attribute of the cloud for us is that it is fully disintermediated. There's nothing between an end user and the resources that they want. If I need some compute, bang, I get it right away. If I need some storage, bang, I've got it. We use Chef as our infrastructure automation tool. If you're not familiar with Chef or Puppet, Chef turns hardware into software. I'll talk more about that in a little bit. And over the past several years, we've been developing more of a DevOps culture. We were kind of forced into it. Cyber is a very small organization, and if we wanted to get anything done at all, we pretty much had to do everything ourselves. It's kind of exciting, and I like it. We like working that way. The project also took a lot of collaboration with the institutions. This was a really interesting aspect of the project. We found that every institution had a different set of goals, a different approach to the project, and a very different personality to it. It was really interesting, and it was really challenging. And the project also took a lot of humility on our part. We were walking into a situation where we didn't really understand the system. We were not the experts. So it took a lot for us to get used to that, to get used to be in the position where we had to ask a lot of questions and find out a lot of things. Oh, I should say that everything that we used in this project, it's all open source software. Again, we're a small organization. We can't really afford expensive, closed, proprietary systems, and neither can you. I should say a little bit more about DevOps. It's a growing trend. It is a coming together of the best practices from the development communities and best practices of the operations community. It's all about tearing down the silos and divisions. There's traditionally been a lot of tension between development groups and operations group. Developers are accused of throwing code over the wall and letting the operators have to deal with it. Those days are gone. DevOps forces you to think about the entire stack, not just the application layer, not just the network layer, not just the hardware layer, the whole thing. And it's good for you. Part of being a DevOps is that I'm a developer. I come at all of this from a developer background, and now I find myself as one of those guys offering the 24/7 support. I'm the guy who gets those 3 a.m. phone calls. So as part of another system, the phone goes off. It's in the wee hours of the morning, and I'm not accustomed to this, and I'm in this weird state of being half asleep and on the verge of panic. And I'm looking at this error message, and it's completely incomprehensible. It's one of those terrible error messages. You know the ones. They're no help at all. And what really infuriated me is that it was my error message. I had put it in the system, and it was worthless. So I changed it the next day. So there's another good thing about DevOps. The distance between operations and development is 0. I can switch hats. I promise I do not write terrible error messages anymore. In fact, I don't write error messages. I throw out lifelines. So infrastructure automation, this was a key part of the project for us. It's what we were interested, what Cyvera was interested in this project. The zealots call it a revolution. Maybe that's wrong. Let's just call it an evolution. It's all about turning hardware into software. And if you say that a couple of times, it sort of becomes fantastic and magical. Hardware into software. So all of a sudden, you get all of the benefits that virtualization and digitization has brought to all aspects of our lives, communications, of compute. I mean, it's everywhere, all around us. And now we apply it to our hardware. It's amazing. So it lets you put your infrastructure under version control, for example. I can diff 2 servers. Once I have such a solid foundation for the infrastructure, it becomes a platform for iterative improvement. I can make tiny changes, all version controlled, all strictly managed, and deploy that across my infrastructure. It becomes a platform for consistency and auditability. This stuff fits great in your change management database. It becomes a platform for documentation and discoverability as well. We ran into a lot of cases in our project where there'd be some dusty little corner of this legacy system that exactly how it was, where it came from and how it was configured wasn't all that clear. Bringing all that together, everything, putting it into one automation system made it easy to discover things about the system. If I can't remember how some weird little service is configured, I just grep for it. It's right there. It's in the source code. So let's see this in action. So let's imagine I want a new instance of our learning management system. It's Moodle, by the way. And I want it to be, I want a highly available configuration. Data is precious, so I want it fully backed up. I want the file system snapshotted. And I need it now. So hit the go button. And the first thing that the automation system does is it starts bringing up application servers, a whole bunch of application servers actually. And it sticks a load balancer out in front. And we've got our database and our file server. And it's Moodle, so we've got a separate cron server. Standby database, local backup for the file system. We install and configure all of the software. This is all going on automatically. We attach a bunch of volumes appropriately sized for whatever environment we're going into. And then we start wiring them all up. So here we're using the Chef automation system. It's got a lot of metadata about each of the servers that it manages. So it knows the IP addresses and the mount points of all the volumes and things like that. And we use that in the automation. Wire everything up together. And let's start our database backups going and our file system snapshots. Let's get that going as well. And we actually have a second redundant cloud. It's geographically remote. So let's start up a disaster recovery server in there with a bunch of volumes on it. And let's get the backups going in there automatically. And boom, it's done. And I haven't even finished having my coffee yet. So where are we now? We went into live production in November, and nobody noticed. I mean, it was kind of anticlimactic. A lot of effort and preparation to get there, and then we flipped the switch, and it's just dead quiet. It was so smooth. 99.97% uptime. That's okay. It's nothing to scream about. But I'm happy to say that there has never been a failure of the infrastructure. The only reason why we don't have a bunch more nines there are little network blips. And that can be in our network provider or in the networks of the various institutions and whatnot. But there it is. Better performance than bare metal system. We were pleasantly surprised by this. There's a lot of fear and uncertainty and dismay around the virtualization of databases, and we were a little cautious about this too. But in fact, it's just not a problem. None of the systems we've ever worked on has gotten anywhere near the point where the virtualization of overhead has been the bottleneck. So put your systems in the cloud. They work great. 4 institutions, 1 more coming later on this summer. I don't know what, 185 servers. We've got 17 environments now. And all of this is supported by 4 people. We have it set up so that 2 people sort of handle the day-to-day issues that come up in supporting the system, and 2 others continue to develop the automation systems. This was important to us. Like I said, Cyvera's interest in the project was to figure out how this infrastructure automation works and how we can use it, and to find out just how efficiently or how much efficiency that kind of automation can bring to a system. So, that's not bad. 4 institutions, really, supported by 2 guys. Pretty good. And all of our stuff is open source. We're on GitHub, so fork us and let us know how it goes for you. What did we learn? Well, I guess the most important thing is that we learned how to migrate applications into the cloud. It's not a straightforward and obvious path, but we found that it can be done. We found that you can do it with legacy systems, important legacy systems that institutions really rely on. And we learned a lot about how to take an older system and how to apply newer automation techniques to it. And we're learning now how these systems evolve in the cloud. I've got a point about that later on. And we learned that a lot of the ideas around DevOps and infrastructure automation, it really challenges traditional procedures and culture in the environments, in the institutions. And of course, it's hard work, but it does work. I want to just sort of step outside the presentation for a moment and say a little bit more about this. The University of Alberta held us to ridiculously high standards. They were extremely demanding, and they were right to do so. They had an uptime and a service record that anyone would be jealous of, and they got it by being real careful and real good. And they would have been real stupid if they lowered their standards by 1 drop just because we came along. So it was hard work, but it was totally worth it. And I'm glad we went through it. So this is more sort of on the same theme. a lot of the University of Alberta and a lot of the other institutions, they have ITIL systems in place, and they have, like every institution, has got compliance systems that you have to satisfy. So it was difficult to find a balance, to find a way to satisfy the compliance systems, which are important, and find a way to satisfy them with these new ideas about DevOps and infrastructure automation. It's difficult to reconcile the traditional models where environments are, must be absolutely stable with this new model of dynamic systems. You should have seen the look on their project manager's face when I told them that the infrastructure would be changing constantly all through acceptance tests, or that I was going to throw away this database server and replace it with another one. Oh, but it'll be identical, I promise. These are alarming ideas to any sensible person, but it's what we were trying to do. So there is a tension there. It's a healthy tension because it forces movement on both sides. A lot of compromise and a lot of trust is necessary. And trust is earned. We had to work really hard to demonstrate that a dynamic system could be stable. We've done that, right?
Mm-hmm.
Okay.
Absolutely.
You are not the expert. So you just can't automate what you don't understand. And to the understanding, we learned that the understanding of a legacy system is sort of spread across a bunch of different silos in the institutions. There's no one person, no one group that knows how the entire system is configured. So we spent a lot of time talking to a lot of different people, trying to pull all these threads together and weave them into a single automation system. Right, so automation style. So we found early on that a lot of our automation, it worked great and it hid the complexity of the system from us, and it made operations very easy until something went wrong. And when you had to sort of step outside the bounds of the automation, we found it actually got in the way. So we learned that it was better to build the automation in a way that you can easily open up the cover and start working with the individual pieces. I might want to use part of the automation and then do some manual things and then do another part of it. So we call it just-in-time complexity. So we want to hide that complexity when we don't need it, but we want to be able to easily expose it when we do need it. Discoverability, the ability to search through the system quickly and find find how a system is discovered, or find the other parts of the system that it communicates with. Prescriptive error messages, I said something about that before. Don't just tell me that you can't talk to the foobar service, tell me what I should do about it. Tell me how to restart the foobar service and then how to restart your service. Throw me a bone. And it's important to take a more mature attitude towards error, a more tolerant attitude towards error. They're going to happen. I don't care what system you have in place or what processes you have in place, it will fail. And all of the efforts to try to squeeze out those errors and eliminate them, it just adds complexity to the system that gets in your way in the middle of a crisis. So you want to set a system that is tolerant of errors, that is simple, so that when it does fail, you can restore it quickly. So value the mean time to recovery more than the mean time between failures. So what's next? So I've described our architecture, which we are justifiably proud of. But the problem is that it's yesterday's architecture. This is a typical web application from the early 2000s. And it doesn't really take any advantage of the features that are available in the cloud infrastructure. It was good to learn how to take a system and a legacy system and move it into the cloud. It's possible, but that's not where it stops. What we really want, and this is where we're going over the next year or two, we want cloud architecture. We want applications that don't have a single point of failure. Moving to more of a model of redundancy rather than failover, big bang failover. We want systems that assume and can take advantage of the elasticity of compute and storage. And for heaven's sakes, I mean, why should anyone in this day and age, why should we have to build our own data replication systems, our own file system snapshotting? We want cloud infrastructure where things like distribution and replication, they're just properties of the cloud fabric itself. If I put an object somewhere in cloud storage, it's automatically replicated and distributed and available for me. Monitoring. This is worth an hour-long presentation all on its own. I used to think that monitoring was, I don't know, maybe looking at a log file every once in a while. No. Monitoring is its own art form now. It's evolving very quickly. There is an explosion of new tools and new capabilities. And there's also an explosion of new expectations. Every part of your system, of your infrastructure, can be monitored now, and there is an expectation that it will be monitored. This is sort of my, it's sort of turning into my new hobby, I suppose. So Scott, how do we do it?
So when we started in this, we were looking for Cyber to provide the U of A up through the database layer. We've got our own local team of pedagogical support, technology support people. And what we found was that you have to integrate a little tighter than that, which is what Barton had referred to earlier. So where are we? 99.97 uptime. Again, a lot of the 0.03 has been associated with networking. When we were running locally, so virtualized, yes, at the U of A, in our own data centers, we had 90 minutes of unscheduled downtime in over 800 days. That was because a UPS catastrophically blew up in the data center to the point where APC flew out to take a look at it. But other than that, the environment was up. And so the environment itself has been up 100% of the time on Cyber. It was actually faster in the cloud than it was running locally. And some of that's because our virtualized servers are a bit better now than they were back then. But we went from page load times of a third of a second locally, and we shaved that down to 0.283 seconds locally in the winter term of 2012. And now on the cloud, we're down to under 0.2 of a second for page load. So this is from when we fired up Moodle back in 2011. This section here is where we're up in the cloud. So everything from here to the left is local operation. So we had 460,000 page views in a single day on Cyber. And so each tooth of that saw that you're seeing there is a week. So Saturday is our low day. Saturday is not Nate's low day. So again, being in the cloud with your other partner institutions, not everybody's schedule is the same. So we average 300,000 page views a day. Unique visitors, we get about 24,000 unique visitors per day. And when we came on, Nate was holding their breath. They're like, oh my God, here comes the Colossus. They're gonna wipe us down. Our page loads are gonna go to a second. Our students are gonna complain. And they didn't notice when we came live. So they went live in November because their schedule's slightly different than the U of A. We went live in January. And they didn't notice us coming into the same cloud that they were running in, which speaks to the planning that Cybera put into this. Nate has 99.77% uptime, and this is because of their connection to SuperNet, mainly. And while I've not heard what their uptime on local operation was, it wasn't this. And so Daryl Allenby of Nate says, well, we are very happy that it has gone up. And when the LRT in Edmonton runs to the Nate campus, there'll be fiber between the U of A and Grant MacEwan University and Nate, and their network issues will go away. So I'd like to address some of the common questions I get asked. Cost. So Cybera determines what the overall cost for a year is. We pay it in 2 installments. The first payment is an estimated half in the fall, and the second payment reconciles everything down to the penny sort of thing. So what we do in Alberta is we take that overall amount. Each institution pays $10,000 up front as a nuisance fee. We don't want the tiny institutions coming along and absorbing all of the resources by asking a ton of questions, or larger institutions who are just getting started. So we don't want people dabbling forever saying, well, we're not really in production. We're still testing. We're only running 20 courses this year, and 20 courses the following year, and 30 courses the following year, and they never actually jump in the pond. So the 10K is kind of a, don't be a nuisance. And then we take the balance and divide it out by the full-time learner equivalent. So yeah, U of A right now is like over half of the number. And we use the numbers as they're reported to the government. So this means there's no penalty for adding a course. We didn't want any of the schools to say, oh, sorry, instructor X, but we can't afford to add your course because we're being charged per course and the budgets are tight and this just didn't work. So we do it by FLE count so that they're not penalized for adding a course. And that also means we're not penalizing the post-secondary institutions that have a great number of part-time students. So we didn't want to go with head count because that would penalize some of the small schools that have a high number of part-time students. So as this succeeds in year 1, we'll expand beyond the current set of institutions, which are on the left there, with our partners in Cybera, and we receive some, wow, that's really hard to see. Alberta Enterprise and Advanced Ed funded some of our startup costs. So we're looking to expand beyond to other institutions. Norquest was not one of the original partners, but came on. We have another small school in Alberta, Portage College, who is currently hosted out east and is looking to run things closer to home. And then University of Lethbridge is interested, and Lethbridge College. So we're offering a service that works for a school the size of the U of A. So the U of A has roughly 38,000 students, 34,800 LE. To schools that are far smaller, Norquest has 4,000 students, and some of the other schools like Portage are like 1,500. You can't, as a 1,500 student institution, have an infrastructure that will suit and have uptimes like what we're demanding. So allowing them to piggyback on this for something that costs them less than one FTE technical salary is a huge win for them, and also takes the headache of capital costs away as well. So if this is successful, then we're looking to go to other services. Originally, we thought the next service would be something like Alfresco for electronic document and records management, because the U of A is looking to use that. Athabasca is already using that. Nate's looking into it. But what we found was Adobe Connect is likely the next one for us. The U of A has just switched away from Illuminate. Yeah, we weren't on Blackboard Collaborate yet. We were still running Illuminate 9.7, so we were really out of date because we were switching to Moodle. So all of those educational technology support people were working in that environment. And now that we finished that migration, then we went, what else needs fixed? And it was our synchronous learning tool. So we've selected Adobe Connect, and Nate uses Adobe Connect, Athabasca uses Adobe Connect. There's some institutions further south in Alberta that use Adobe Connect. So that's likely this next service that we're looking to move to the cloud. So at this point, we'd be glad to take any questions.
I wonder if you can explain why you use Chef versus Puppets, if that can.
Great, yeah, yay. Okay, so we actually had some experience using Puppet before. We used Puppet to manage our physical infrastructure at Cyberra. So here's an opportunity to learn what a different automation tool. So we'd be able to compare Puppet and Chef. So in fact, for this project, we have Puppet managing the physical infrastructure of the cloud, and we've got Chef managing the virtual layer. Works fine. We found that Chef is probably a little better suited for handling dynamic environments like might be typical in a cloud situation. It's the metadata that's used in the Chef server that makes a difference. We also like the pure Ruby aspects of it, but that's perhaps just a stylistic thing.
So these servers that you're running are all linked, or?
Well, let's see. The virtual servers are Ubuntu Linux, Postgres is the database backend, Apache server. What am I missing there?
But like the whole cloud itself is.
Sorry?
All the different servers that are equivalent.
Well, they all run the same Ubuntu operating system, but they're the virtual resources are scaled differently. We throw tons of RAM at the database server, for example, and the application servers got less RAM.
And are you doing VMware or something else?
No, we use OpenStack for the cloud.
Oh, okay.
So KVM is our hypervisor, OpenStack is the cloud fabric. Yeah.
Could you just describe briefly the infrastructure, the actual hardware infrastructure that's in place?
The physical infrastructure. Let's see. We've got in 2 data centers, we've got, I can't remember the count, something like half a rack of Dell 6220 servers. All of the hardware is homogeneous. Storage for the cloud is evenly distributed across all of the servers, which is a decision we might not make if we were doing this again. Turns out that when you do it that way, the largest virtual volume that you can create is restricted by the amount of physical disk space on a single node. If you use a storage appliance, that limitation sort of goes away. Next time.
Because this is on LMSs, students are accessing it on that application. Does Cyberra have a peering of ISPs?
I don't even know if I can answer that question.
Well, so in Alberta, a lot of people are either on Shaw or TELUS, and so those are going to be interconnected. I'm sure JF would say interconnected well with Cyberra as our ORAN, right? So the people that are on campus, we're connected by 10 gig at the U of A.
Yeah.
So
And,
campus isn't a problem.
yeah. So if,
And Nate's on SuperNet right now, which is a Bell Axia fabric across the province for schools and health facilities and the like.
yeah, so if you're on any of the campuses, then you're on the Research and Education Network, and you've got, really good, fast network. If you're at home, then you're coming to the cloud across commercial internet, and your mileage may vary. But of course, once you're in the cloud, then again, you've got the very fast network. So data transfer times and things like that are good. All of the
Which
network.
we were testing with our page load times and things like that.
All of the network is redundant. We were very careful to try to avoid any single points of failure in the network layer. And there have been lots of times when there's been some event on one of the links, say there's something terrible has happened on the Research and Education Network, and so all the traffic just automatically flows over commercial internet, and vice versa.
But we love being able to address audit points by saying that this is physically redundant, even for, some of the small schools, where they didn't even have an expectation to be able to address that if they were running locally, because they don't have data centers, 2 different campuses or anything like that. That comes along with joining the partnership.
Right, yeah, so we wanted to come up with a system that was robust and safe, and the attributes of the automatic failover and the automatic, don't say that, not automatic failover. We always want to have a human making that decision. But the automatic backups was important to us, and we were thinking mainly about the smaller institutions that don't really have the capacity, the resources to manage that kind of thing. Norquest was the most recent group to join us. They just came on a couple of weeks ago, and there's a lot of overhead in sort of setting up these projects, with setting up cloud accounts and credentials and all that kind of stuff. And we got the word go early in the morning, saying Norquest had agreed and they were going to join us. And by mid-afternoon, I was able to give them a fully functioning Moodle cluster. There it is. It's theirs to work with. Of course, it had no content in it or anything like that, but there were no roadblocks. They could proceed at their own schedule. They didn't have to wait for us. So again, that was very important to us.
I think time's up now.
Okay.
Thank the speakers.